The line tangent to a point on a function shares the slope of that point. And in nonlinear functions, the slope is unique at every point. The derivative is the slope at or very near a point on a function. We can zoom in on this point and displace its x by a small value dx and its y by a corresponding value dy. The slope between the point and the new point created by the displacement is dy over dx, and we can approximate the slope directly at the point by making dx smaller and smaller. We can rewrite dy over dx. But dx implies a value very close to 0, so we can simply replace it with the value h and say that h approached but never reached 0. We can say this with a limit. This is read as the limit as h approaches 0. We now have the formula to calculate the slope directly at a point on a function.